All right, now we're going to graph a few equations, find the axial intercepts, create a table of sample points, plot those points and sketch the graph, and then do a test for symmetry. We'll be using the odd and even algebraic tests. But these particular equations are a little dull, they're a little boring for some of these, so we're going to change them just slightly. We're going to change this to just minus 3. So we're going to have f of x equals x squared minus 3. Let's go ahead and build a table of sample points for this first function. We have our x and y. Let's pick a few points. -2, -1, 0, 1, 2 are good starting points. If you plug -2 in here, -2 squared is 4. 4 minus 3 is 1. Plug -1 in for x. We have -1 squared. -1 times -1 is +1. Minus 3 is -2. 0 in. Well, 0 squared is 0. Minus 3 is -3. Plug 1 in. 1 squared is 1. Minus 3 is -2. 2 squared is 4. Minus 3 is 1. Let's do another point. 3. 3 squared is 9. Minus 3 is 6. We could continue on. 4 squared is 16. Minus 3 is 13. But we're going to get off of the graph at that point. So let's go ahead and plot some of these points. -2, 1. -1, -2. 0, -3. 1, -2. 2, +1. And then 3, 6. 1, 2, 3, 4, 5, 6. And 4, 13. Clear up there. We can kind of sketch this. We can stop grabbing points because we see that it's symmetric about the origin. Excuse me, about the y-axis. There's a line of symmetry across the y-axis. Find the x and y intercepts. Well, as we know that this is the parent function x squared, this is just shifted down 3, and so the y-intercept is -3. So the y-intercept is the point 0, -3, or oftentimes we just say it's -3. X-intercept. Here we set, like we did here, we set x equal to 0. We're going to set y equal to 0. So when we set y equal to 0, we can rewrite this as 0 equals x squared minus 3, add 3 to both sides, and then take the square root. So we're going to have x squared equals 3, x equals the square root of 3. But when we take the square root of that, we need to consider both positive and negative choices, because two negatives multiplied together do make a positive. So we have 2 points that are zeros, or roots, right here and here, where it's negative square root of 3 and positive square root of 3. So we have plus or minus root 3 as our intercepts. So we've found the x and y intercepts, if they exist. We built a table of sample points and sketched the graph. Now we need to test for symmetry by using the algebraic test. The test for symmetry is inserting -x into the function and seeing what the result is. If we insert -x into our original function, we'll have -x squared minus 3. While evaluating this, -x times -x is simply positive x squared. And so there is no change. This is the same as our original function if we insert find the f of -x. This conclusion, this result gives us a conclusion that this function is even. Let's look at the next equation. Again, it's a little bit dull, so we're going to change it because this one is going to end up being even. We want to change this, so that's a 3. Now, rewriting this, y equals negative 1 over x cubed, or f of x equals negative 1 over x cubed. We'll do the same thing as we did before with an xy table. Negative 2, negative 1, 0, 1, 2. When x is negative 2, this is going to be negative 1 over, see, negative 2 cubed is negative 8. So this is going to be negative 1 over negative 8, or just 1/8. When x is negative 1, again, it's still going to be negative because 3 negatives multiplied together is a negative. So it's negative 1 over negative 1, which is positive 1. When x is 0, well, you're dividing by 0. Even on a Monday, which is today, we can't do that, and so that's undefined. When x is 1, we have negative 1 divided by 1, which is negative 1. When x is 2, you guessed it, it's going to be negative 1/8. It's going to be really the same as the negative 2. When we have, or at least the opposite, let's go ahead and grab 3. Negative 1 divided by, well, 3 cubed is 27. That's negative 1 over 27. That's not very interesting. It's getting very close to 0. Let's grab some fractionals, some fractions in here. Let's try 1/2. If we plug 1/2 in for x, that's going to be, let's think about this. 1/2 times 1/2 times 1/2 is going to be 1/8. So this is negative 1 over 1/8. We can rewrite this as negative 1 divided by 1/8. When we're dividing by a fraction, we're going to multiply by the reciprocal, which is negative 1 times 8 over 1, which negative 1 times 8 is negative 8. Well, that's interesting. What if we do 1 over 10? Well, that's going to give us a similar result of negative 1 divided by 1, well, 10 cubed. Well, let's see, that's 10 times 10 times 10, that's 1,000, which is the same as negative 1 times its reciprocal, or 1,000. Well, negative 1 times 1,000, I like multiplying by 1. That's fairly easy. I don't need a calculator for that. That's negative 1,000. Well, that gives me an idea of what's happening here. So let's go ahead and sketch these, graph these points and sketch the graph. Negative 2 was 1/8. Right in there. Negative 1 is positive 1. Right here. 0 is undefined, so we probably have an asymptote, or at least a hole. 1 is negative 1. 1 is negative 1. 2 is negative 1/8. 3 is negative 1/27, even closer to the line if we can. It's going to mirror on the other side, but 1/2 was negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Right here, 1/10 was negative 1,000. Well, it's going to get asymptotically close to 0. We always enjoy saying that word, asymptotically, because it makes us either feel smart or dirty, whichever one you want. So you can imagine this is getting asymptotically close to both axes so that just means it's not touching them. What happens with the graph there? So we have the graph getting close to the x and y axes. What else do we need to do? We've got the sample points, we've created a sketch, we haven't tested for symmetry, and we have not found the x and y intercepts. Well, what are the x and y intercepts? Well, there aren't any. If we have 0, plug in 0 for x, where it's undefined for y, so we don't have a y intercept. If we plug in 0 for y, we have 0 equals negative 1 over x cubed. Well, we've got to get x by itself. That means it needs to be positive in the numerator with nothing else around it. So we multiply both sides by x cubed, and we have 0 equals negative 1. Again, I may be sleepy on a Monday, but 0 does not equal -1, so this cannot exist. So it just does not exist. That's another undefined, or it just does not exist. And so there are no intercepts. Well, let's test for symmetry. We're going to do the same test. F of -x equals -1 over -x cubed. What happens when we cube -x? Well, it's again 3 negatives multiplied together is another negative. So this is -1 over the opposite of x cubed. Simplify that. Negative over negative is a positive. 1 over x cubed. Well, this f of -x is the same as our original function. It's just the opposite of it. So this is equal to the opposite of f of x. When we have this result, the conclusion is an odd function. Here we have an example of an even and an odd function.